Hey, I'm Annie Hin, a science communicator from SJSU. Come with me to learn a bit about some research being done in our geology department. Here at SJSU, our geology grad student Ashley Walsh is actively studying the role of the active San Gregorio Fault and the growing landslides at Pillar Point. She's investigating how the geometry and angle of the fault influences the landslide rate. Ashley conducts monthly fieldwork excursions with the help of other SJSU students to map the surface of the bluff with LiDAR. The collected data gets compared to public data collected by NOAA, available on Open Topography, a public repository for LiDAR data. In 1 month, both Ethan Failano and I assisted Ashley with collecting and processing LiDAR to analyze this landslide's data. You may be wondering, what are active tectonics and who studies that? Active tectonics are ongoing tectonic processes and fault motion that's recorded on Earth's historical time. And here in Moffett Field, California, we have the USGS Earthquake Science Center. Their mission is to collect a wide range of data on earthquakes, faults, and crustal deformation. By monitoring earthquake impacts and seismic hazards, the research conducted in these laboratories and facilities greatly benefit the protection of people. Now, as I mentioned earlier, Ashley, Ethan, and I have been using LiDAR to collect data on this landslide. What exactly is LiDAR? LiDAR stands for Light Detection and Ranging. Essentially, LiDAR uses pulsed lasers to measure distances and create highly accurate 3D maps of its environment. It's a technology that uses lasers both side to side, horizontally scanning the area to create a 360-degree horizontal view, and up and down, using the laser beam to move vertically and measure elevation and height profiles. That combination creates 3D point clouds, where we can then see incredibly precise maps. Our system can map up to 80 meters left and right of its sensors, and fun fact, the lasers are safe to the human eye. It is especially useful to map deformations on Earth's surfaces because its lasers can see past vegetation, soil, even eliminating motion-sensed objects such as people or animals to see surface changes with accuracy and precision. It can reveal activity that isn't easily visible. In Ashley's research, we pair the GPS to as many satellites as possible to calculate an accurate position in real time. The IMU on board of the LiDAR unit is the sensor that measures motion and orientation. To function correctly, it requires kinematic alignment, essentially calibration. We turn the LiDAR on and allow it to get accustomed to its environment for about 5 minutes. Afterwards, we move it straight for 5 to 10 seconds before moving in figure eights so that it can kinematically align itself. It's all good to start collecting data. LiDAR can work in many modes. In Ashley's case, she uses both the truck and the backpack. The truck is beneficial in being able to collect data by simply driving around. It can be pretty scary driving it straight for 5 to 10 seconds since we have to floor it in a very bumpy environment. The backpack is great for walking closer to the more unstable landslide locations, therefore getting better data. Not only can LiDAR work well in trucks or backpacks, but it can also be attached and flown via drone. Why has Ashley chosen to study Pillar Point specifically? The San Gregorio Fault is exposed on land in this area. As said before, Pillar Point is one of the only 2 locations where the San Gregorio comes on shore. Movement from the fault and landslide actively affect home and restaurant owners who have resided on the bluff for generations. Their foundations and pipes have been damaged because of the movement. Pillar Point has many dynamic forces at play, such as the active fault movement and potential creep along with the landsliding. The importance of understanding landslides and fault movement is crucial, so let's make sure we know the fundamentals of what to do in the event of an earthquake. First, check where you are. If you're indoors, stay inside. Get under a table and hold onto it. Practice drop, cover, and hold on. Stay away from windows, fireplaces, and heavy furniture. Get out of places that could have things fall onto you, such as kitchens or rooms where things are stacked high. Let's check your knowledge. Fact or myth? Stand behind a door frame if you're inside during an earthquake, as it's the safest spot in the house to be. Myth. This myth was created due to a collapsed adobe home that had its only standing portion being the doorframe. In modern housing, you are safer under a table, as doorways are no stronger than any other area in a house. If you're outside, stay away from buildings, power lines, chimneys, and anything that may fall on you. If you're driving, move your car as far out of traffic as possible and stop carefully. Do not stop under a bridge or overpass, or in general, any areas where things such as light posts or signs may fall onto you or your car. Stay inside until the quaking stops. Generally speaking, get away from anything that may fall on you. If you're near the ocean, watch for news of potential tsunami warnings. Let's make an earthquake kit together for one. According to the USGS, we should include water that'll last me at least 2 weeks, meaning at least 1 gallon per day, purification tablets or chlorine bleach to purify drinking water if I may need water from other sources, canned and packaged non-perishable food that can last me and any pets several days, a mechanical can opener, a camp stove or barbecue to cook on outdoors, a fire extinguisher, adequate medications that you may need, tools needed to turn off gas and water supplies, a first aid kit, flashlights with extra bulbs and batteries, portable radios with extra batteries, and finally, a waterproof, heavy-duty plastic bag for proper disposal. Thanks for following along with learning about LIDAR, earthquake preparedness, pillar point, and landslides. See you next time!